Hello, math nerds. I'm back again. I'm ready to tackle C. How about you? It's Kitty Morgan here, ready to have some fun. All right, here we go. So, looking at C, well, my pen's not working. There we go. Looking at C, here we go. Find the absolute minimum value of G on the closed interval from -2 to 4. Justify your answer. All right, when we were back in the first semester, um, and I got to stop and comment, that's why this problem is so cool, because we're using all the stuff from the first semester to talk about stuff with integrals, so we're mixing it up. That's so fun. Anyway, so when we found the absolute value of G, we had two places to look for. We had the critical points, and that's where either the derivative, and this is G, so that's either where the derivative is equal to 0 or undefined, right? And then we had the endpoints. And I don't know if you remember this, but that's called the candidates test. So the extreme value theorem guaranteed that you would have an absolute max or min on a continuous function, and then the candidates test told you where to look. So there's your two places. I only see one critical point on the graph, and it's at x equals 3. And notice that the graph goes from positive to negative. Oh, I got to make sure what I'm looking at, right? So I need to look at that relationship we talked about again. So I'm going to write this. This is what I call the key to this problem because it helps me read it. So if you want to find values of G, you have to collect area. But then we talked about in the last section, if you want to talk about the derivative, then we really need to look at the function itself. So I have to analyze this function, and when I do, I have to kind of think about what I'm really trying to do and how I have to look at this function to find these values that I need. So if I'm trying to find out where the derivative is equal to 0, because that's what I'm trying to find out, what I'm really trying to do is find out where f of x is equal to 0, because they are equal. See that relationship? So you've got to kind of figure that out. That's why I went over here and circled the 0 on the graph, because that's where this is f of x, that's where f is 0. Okay? And then when you find out where your derivative is 0, you need to see if it goes from positive to negative or negative to positive around it. So I notice here that this graph goes from positive to 0 to negative. And then I think about that going increasing to decreasing, right? So that would be an absolute max. And we were asked to find the absolute min of G. So if the only critical point we have has a maximum on it, then the endpoints are where we need to look for our absolute min. So our endpoints are -2 and 4. So I need to know what G of -2 and G of 4's value is. Oh my gosh, look, didn't we do that in A? So let me think back. Let's see, G of -2, I believe, was -6. And we did that, remember, we did the area from 1 back to -2, and it's a triangle, but because it went backwards, it was negative. And then I believe G of 4 was 5/2, and we did that by computing the area from 1 to 4. Remember that? Okay, anyway, so now that we know those two, of those two endpoints, which one is the smallest, and that would be your G of 2 equaling -6. So because of that, it said find the absolute minimum value. Oh goodness, I did not mean to do that. The value of G. And when they ask you for the value, they're asking for the Y. So the answer to this question is -6. And we can justify our answer by talking about at x equals 4, excuse me, at x equals 3, there's an absolute max. So we check the endpoints, and then that's our work for that, and then that's the minimum value. Okay, so that's part C. Come on back for part D for a little later.